Okay, Assalamu alaikum, Bismillah Rahman Rahim. This is in principle going to be this is going to be lecture number 1 in principle. So far, like we have been following this course in a very non-linear fashion, but this is how it was supposed to be. So this is lecture 1, and let's get started without further ado. So this is the outline for this lecture. First of all, we are going to talk about the course. What are the objectives? The objectives set by the people who put up this course together. What are the learning outcomes that we are going to achieve? So the learning outcomes are very important. You should know these learning outcomes, and whenever you're trying to whenever you're doing something in this course, you should keep these learning outcomes in your mind, because this is what we are trying to achieve. After this course, you should be able to do what these learning outcomes state. Then we'll go through the contents of this course, and then I'll outline the list of readings for this course, the books basically that you can refer to during this course. And then we'll talk about how this course is officially organized. So you know how this is organized, but briefly we'll talk about that. Then we'll talk about, in general, what is meant by computer programming, what are computers, what is programming. Then we'll talk about computers and programming in a little more detail. And this is something that we'll refer to again and again in this course at different points in time. So this material would be repeated in the future lectures as well, and I hope by the end of this course you will have a very clear idea about what computers are and what do we mean by programming a computer. And I hope you should be able to program computers at least in the language C++. That will be the language that we'll learn in this course. And I also hope that you'll also be able to learn another new programming language, a different programming language than C++. So let's get started. Now, what are the course objectives? What are the objectives for this course? So this course is intended to basically introduce you to what algorithms are, how to develop algorithms, what computer programming is, and how can we program a computer in any language such as C and C++. So we'll be using C++ language in this course. Now there are plenty of new languages around, and sometimes people start thinking that maybe C++ is a bit old-fashioned, but still most of the software that you use, for example Microsoft Office suite of applications, Microsoft Windows, the Linux operating system. So the Linux operating system is mostly developed in the language C. So C is a systems programming language. All system software like operating systems, device drivers, compilers, assemblers, so all these tools, they are mostly developed in the language C. Why C? Because C is very powerful, C is very efficient, C gives you a lot of performance. So that is why people mostly like to use C. And C++ is basically an attempt to improve C, enable C to support different programming paradigms. So the way you think about problems, the way you can model problems, and the way you can basically come up with solutions. So C++ basically enables that. Like you can do object-oriented programming in C++, which was lacking in C. Similarly, we can use generic programming in C++, which we couldn't do in C. Now, some people may like that improvement in C, and some people may not like those improvements in C. So you can have a wide variety of opinions about that. But this is how it is. So these are the course objectives. Basically, it is to teach you how to use computers for solving engineering problems. That is the essence of this course. You should be able to use computers in order to solve different problems in mechatronics engineering. Okay, so that is the purpose of this course. Now, what are the course learning outcomes? What do we want to be able to do after we have studied this course? So first of all, you need to understand fundamental computer programming concepts. Sorry about this background noise. We will have plenty of this noise in during these video recordings. It is difficult to find a very quiet spot, especially in this weather. So, first of all, we need to understand fundamental computer programming concepts, and that includes like what are computers, what is programming, what are programming languages, algorithms, editors, compilers, and linkers, and linking, and all these things. And then we are also going to learn about the fundamental programming constructs of these different languages. Like if you need to program your computer, if you need to instruct your computer to do something, how can you do that? Okay, so all these are included in the fundamentals of computer programming. So we learn about that, and you should be able, like you should, this is your checklist. After you're done with this course, you need to check or uncheck one of these two, like am I able to do these things? Do I understand the fundamental computer programming concepts? Can I apply whatever I learned to solve problems using computers? This is the second, this is the most important part of it. Like the understanding would be measured in your ability to apply that knowledge to solve problems using computers. Those problems would be very simple. We'll start with very simple, and then we will build upon the complexity of the problems. Okay, but you should be able to solve any problem using a computer. So these are the two course learning outcomes that we'll try to achieve. The course contents, you can go through these in details, in more detail. This is a lot of text. I'll briefly go through it. First of all, we need to understand the organization of a computer, like how the computer is organized. So this would be not a very detailed but a very superficial or abstract organization of a computer. So we look at how the different components of a computer, what makes a computer system. So we'll basically address that question. What is a computer? What are the essential components of any computer system, be it a laptop, a desktop, or any other type of computer. So computers are not just limited to laptop computers or desktop computers. We have embedded computers. More and more devices, more and more appliances, they are coming with computers that are embedded inside them. For example, the cars have around more than 50 plus, or in many cases more advanced cars, they have hundreds of computers. And if you are following the news, so you might be hearing about chip shortages that are basically hurting car manufacturing. So now different manufacturers, like they cannot manufacture cars because they cannot find the small computer chips that go into those cars. Okay, so why is this chip shortage? So you can look up those details. It is at times it is very useful to follow news in order to stay updated about all these things. So we learn about computer organization, like what makes a computer, and in fact we'll do that in this particular lecture. What are algorithms? What are computer languages? What is a compiler, assembler, interpreter? We'll learn about these. We'll be using, in fact we have used an IDE. IDE stands for Integrated Development Environment. So we are using code blocks. Here they talk about Microsoft Visual C++ 6. This is an old one. Right now Microsoft, I guess it provides Microsoft Xcode, and maybe Microsoft Visual Studio, but the one that you can get freely, I guess that is Microsoft Xcode. I'm not sure about the name, but I guess that is what it is. Then we'll talk about data types, data representation. For this particular lecture, data representation and data type, I may refer you to a couple of other pre-recorded lectures that were recorded for another course, but nevertheless they're useful for understanding all these things. Identifiers, reserved words or keywords, variables, and constants. We have talked about many of these things before, and we'll do it again and again in this particular course. Inputs and outputs, like how do you get input from the user and how do you output to the user. Arithmetic and logical operators, They talk about the standard template library. We may not use the standard template library in this course. That would be a little too advanced for you, but we will use the standard library, the standard input output library, and the other parts of the standard library. We'll use that. Okay, so we'll talk about arithmetic and logical operators. I guess we have used arithmetic operators, and we'll talk about other programming constructs like how do you make decisions, how can you repeat blocks of code, how can you create functions or blocks of code that do a particular task, and all these things. So you can go through it. So we'll try to cover as much of these course contents as possible for this course. Now let's. These are the list of recommended readings. Uh, Probably we'll follow the text. Our textbook would be C++ How to Program by Paul Deitel and Harvey Deitel. I guess we have the 8th or 7th edition in our library. If you can get any edition of this book, latest edition, maybe 10th or higher, so that would be good. You can have it and you can keep a copy of it with you. The other books, they are also very excellent books. Programming Principles and Practice Using C++. It is a book by, now this is a hard name to read. Some people read it as Jarni Stroutstrup. Some people read it as Bjarni or Yarni Stroutstrup. So this guy is the creator of C++. He created the language C++. Okay, so you should definitely follow him if you are interested in following anything or any news about C++. So this is his book, which basically teaches programming using C++. Okay, so programming is a little different than learning. Programming is a little different than learning a language. It is like learning to speak or learning to talk. So learning to talk and learning to talk in a particular language, these are two different things. Now there may be people who are very good at writing or speaking. Okay, not necessarily at some particular language, but there may be people who know a lot of languages, but they are not that good speakers. So it is different. Okay, speaking or knowing what to speak and how to speak, this is different, and knowing a language is different. Okay, so there may be people who know English or Urdu or Pashto very well, but they may not be good speakers. And there may be people who would definitely know the language and who definitely know the art of speaking. Okay, so programming is something like that. You may know a particular language, but you may not be a good programmer. A good programmer is someone who can solve a problem using computers. So it needs understanding, abilities to understand the problem or analyze the problem, and then come up with a solution that basically solves the problem. Okay, so this is a different skill. uh, Now it may be like at times we can teach techniques that may help you in solving problems, and if you learn those techniques you would be able to solve problems. But like at times it may be difficult to teach this skill. So some of it comes naturally, some of it you can improve with practice by solving as many problems as you can, and then by looking at patterns in those problems, like what kind of problems or what kind of problems they come up, and how can you solve a particular type of problem. Okay, so this comes with practice. Programming, you learn about programming with practice. You can learn a language very quickly. Okay, but if you want to learn programming, you have to solve problems. Me solving problems will help me. You solving problems will help you. So I'll teach you how to solve problems using a computer, using a particular language like C++, but I cannot teach you how to solve every problem. Okay, so I'll teach you how to solve some problems, and then I'll hope that by with that knowledge you will be able to solve similar problems, or you'll be able to think about solving problems that may be a little different. Okay, so this is a very good book. It is a very huge book as well, around 1200 plus pages, but nevertheless it is a good book. You should have it and you should read it as much as you can. Similarly, this is a short one. It is a tour of C++. You may not find it very useful because you're new to programming as well as C++. So this is around 200 plus pages. If this may be more useful for people like me who know a little more than you about C++ and programming, and this basically can help us refresh things. So this is around 200 plus pages. And then there's another book, the C++ language. It basically follows, or it talks about the standard C++ language. So C++ language is an ISO standard, okay? Just like you must have heard about ISO 9001 or 9000 certified. So these are different standards for different areas. So the C++ language is also an ISO standard, okay? And that standard is basically it makes things very like the language is standardized, and all the compilers, like they it is not mandatory upon them, but all the compilers, they try to follow those standards, okay, implement those standards. So this is a good thing about the C++ language, I guess. I have an old copy of this book. It was second edition. So right now, I guess we have the fourth edition of this book, the C++ language. Again, it is by the same author, the creator of C++ language. Okay, so how is this course organized? So we have a theory part of this course, which is basically 2 credit hours, and a lab part, which is 1 credit hour. So by 2 credit hours theory, we mean like we have 2 hours of classes in which we talk about computer programming theory, and then we have a 3-hour lab session. 1 credit hour of lab session is basically a 3-hour lab session. So this is how this course is organized. We have not been following this schedule very strictly. I'm sorry for that. But hopefully, like in the coming future, we'll organize things in a way in which we can follow this schedule properly. Now let's get started. What is computer programming? Okay. So you can break this term computer programming into 2 terms. What is a computer and what is programming? Okay. So we'll first understand what is a computer, and then we'll understand what is programming, and then hopefully you'll have a very clear idea about what is computer programming. Okay. So since this is the first course that you are taking on computing, so that's why we'll start from the very basics, and the very basics is like, what is a computer? Okay, so a computer is basically a data processing machine. Okay, that is how we define a computer. A computer is a data processing machine. So we have here the term data. Okay, data, and we have the term processing. Data processing. Now, what is data? So basically, data is any fact. Okay, any fact. That fact can be quantitative. That fact can be qualitative. Quantitative facts mean like, what is the temperature today? So say it is around 37 degrees Celsius. So that is a data. Now if we have temperatures for the entire year, okay, say starting from 1st January 2021 up until now, which is around maybe 19th May or 18th May, I don't remember the date today. Let me check. So today is 20th May. Okay, sorry about that. So if we have daily, on a daily basis, we take 2 temperature measurements. One is the minimum temperature, one is the maximum temperature. Okay, so we have from starting from January 1st up until 20th May, we have the readings for say minimum temperature and maximum temperature. So these are data. These are simple facts. Okay, simple measurements of the temperature, the minimum and maximum temperature during the day. Okay, during a 24-hour period. Now this is data. So computers process this data. Okay, computers process this data, and once they process this data, they give you information. So a computer takes data as input and it gives information as output. Okay, data and information. Now we distinguish between the terms data and information in this particular course, but in many books and in many other literature that you may find about computers, they may use computer data and information as terms that mean one and the same thing. That is also possible. But we, for the purpose of this course, we distinguish between data and information. Now, let us look at that the example of our data. So we said that we have temperatures, minimum maximum temperatures from January 1st and up until say 20th May. Okay, so this is our raw data or raw facts. Now, what is the kind of information that we might be interested in? So we might be interested in the minimum temperature during this period. Okay, so that is the coldest temperature that was experienced by say Peshawar or Nowshera or any particular region that we are talking about. We may be interested in that temperature. Okay, or we may be interested in the maximum temperature, the hottest day up until now that was experienced in either say Peshawar or Nowshera or in some other region. So we are in, if you are interested in that information, then you have to process the data. Then what do we mean by that? Then we have to look at all the temperature values that we have, and we have to find the minimum value in that temperature. Okay, so we might have around say how many months have been passed, say for example 5 full months and 30 days, so around 150 readings of minimum temperatures and 150 for higher. So we have around 300 values, 300 numbers. Within those 300 numbers, we'll be searching for the minimum value and the maximum value. So the minimum value will give us the coldest day or coldest day temperature or coldest temperature that was experienced, and the maximum value will give us the hottest day or the hottest temperature that was experienced. This is processing. Okay, this is one example of processing. If you're interested in the average temperature for the month of January, okay, so what was the average temperature for the month of January? So how do we calculate that? So for that, for example, if you want to calculate the average temperature during the day, so the easiest way would be to get the minimum temperature and the maximum temperature, add them and divide by 2. So that will give us the average temperature for any day, for a particular day. It may not be a very good estimate of the average temperature, but it will give us a hint of how the temperature is varying during the day. Okay, so this is the average. This is how we can calculate the average temperature for a day. And if we want to calculate the average temperature for the entire month of January, so then we have to get these average temperatures for every day, and we will need to add them for all the 31 days of January and then divide by 31. That is how we may get the average temperature for the month of January. Okay, so that gives you an idea about like how cold or how hot it is during a particular month in a particular area. This is another example of data processing. So this is what your computer does. The computer takes in raw data and it processes that raw data to give you information. Information is something that you are interested in. So if you are interested in the average temperature for the day, or the average temperature for a month, or the average temperature for the entire year, or the average rainfall for a month, or the average rainfall for a year, or the maximum rainfall for a particular day or for a particular month, so you can get the raw data for that, and you can do some computations on that data in order to get the information that you are interested in. Okay, that is what computers do for you. Now, in order to, computers are data processing machine, so any computer system, it will have these 4 essential components. Any computer system. So be that computer system, be it your laptop, be it your desktop, be it your smartphone, be it your tablet PC, be it an embedded computer that is embedded inside a washing machine or inside a microwave oven or inside your car, be it anywhere, it will have these 4 essential components. One, it will have an input. Okay, it will have some mechanism to sense data from the environment, or to get data from the environment, or to get data from the user or some person. Now you know typical examples of input. So if you have a laptop or a desktop, sorry, so you have the mouse as the input device. The mouse gives you input. The keyboard, you can punch in data from the keyboard. Now you can have input from a sensor. That sensor can be a humidity sensor or a temperature sensor. For example, if there is a computer embedded in your air conditioner, so that computer needs to sense the room temperature, okay, so that it knows when to turn off the compressor or when to turn on the compressor. So it constantly senses the room temperature. It gets measurements, or it reads data, the temperature data from the sensor. It processes that data. How does it process? It compares it with the set temperature. When you take the remote of your air conditioner, you set some temperature on it. For example, you set 26 degrees Celsius. Like, you set the room temperature to be 26 degrees Celsius. You want the room temperature to be around that value. So the computer inside your air conditioner, it would constantly sense that temperature, and it would compare it with 26 degrees Celsius. That is data processing that it does. If the temperature is higher than 26 degrees Celsius, it will turn on the compressor. It will send an output signal, and that output signal will turn on the compressor, okay, and it will constantly monitor the temperature. It will read the sensor constantly, okay, and when the temperature goes below 26 degrees Celsius, it will turn off the compressor. It will send an output signal and turn off the compressor. Now this processing, okay, what is the temperature? Should we turn on the compressor, or should we turn it off? This is done by a program, okay. So there is an intelligent, sort of intelligent, not an intelligent, but there is a CPU inside your computer, and that CPU, we usually call it as a microprocessor, okay. So a microprocessor is basically, it can execute instructions. Like, it can have, you can instruct that microprocessor, you can give it instructions, you can ask it to do some things for you. What can you ask it to do something to do for you? For example, you can ask it to read the value of the sensor that is connected to this microprocessor. You can ask it to do that. You can ask it to compare that value with another value. You can ask it to do addition for you, subtraction for you, or division for you, multiplication for you. You can ask it to send an output signal to another device. For example, you can ask it to turn on the compressor, or to turn off the compressor. So you can do all those things. You have to write those instructions, and those instructions, they are basically, they reside in some sort of memory. Okay. So the program that you write, it resides in a memory. And your CPU or microprocessor, it reads the program that is stored in the memory, and it executes that program, okay. So if you, going back to our example of air conditioner, and to that example, so when you set a temperature for your room, so that set temperature, you see it on the display of your remote, but that temperature is also stored inside your inside the memory of the computer that is embedded in the air conditioner. So that value is stored there as well. So these are the typical components of any computer system, okay. It will have some sort of input mechanism. Now that input can be mouse, keyboard, that is typical of personal computers like laptops and desktops. It can be a touch screen. So the touch screen, it can be a touch screen, it can be a sensor. The sensor can sense or measure temperature, it can sense or measure humidity, it can be a pressure sensor. For example, if you are tire pressure monitoring system, TPMS inside cars, So then in that particular case, we have pressure sensors, and there is a computer or small computer that basically measures the tire pressure. It reads the reading of the tire pressure sensor, and it warns you if the tire pressure increases or decreases beyond a certain limit. Okay, so it warns you about that. It can be a mic. So right now I'm recording this video lecture, and I am using the mic as an input device. So the mic is being used as an input right now. Again, you have used, like, you have smartphones, and in the smartphone you use the mic as an input. You use the touch screen as an input, and you use the camera as an input. So this is not an exhaustive list. You can have other type of input devices as well. Now you take input from these devices, and the CPU, it can store this input inside your memory, and it can process the input directly, or it can store it first in the memory and then process it. So the CPU, it does all the intelligent work in your computer. Okay, so all the arithmetic operations, all the comparisons, and all the data transfer and data processing, all that things, these are done by the microprocessor. Okay, so I hope you know what microprocessors are. So say the laptop that I'm using, it has the Intel Core i5. So the microprocessor that I have, it is Intel Core i5. The microprocessor that is installed in your on your smartphones, so that may be different. So usually I keep on it is an ARM chip. ARM is an acronym for I guess, if I'm not wrong, Advanced Risk Machine, and it is an acronym for another set of words as well. So you are using ARM chips. Okay, if you are using maybe the latest Apple, latest iPhones, you might be using some processors from Apple. So I guess Apple, I don't know how they name the microprocessors or the chips that they produce for the iPhones, but you can look it up. So it would be something like that. This I just wanted to give you hints on what kind of, like, examples of microprocessors. Okay, so microprocessors, they do all the intelligent stuff, all the addition, all the processing, that is done by the microprocessors. Okay, the inputs, they just get you the data. They transform the data into a form that can be used by the microprocessor. Okay, so usually this is basically converted into electrical or digital form. Okay, so say you have different types of sensors. Some sense the temperature, some sense the light, some sense the sound pressure, and all these types of data, they are converted into electrical form. So send input basically does that. It takes care of that interface. Okay, so it converts different types of physical quantities into a form that can be processed by the microprocessor, and that form is usually binary ones and zeros. So it is converted into binary ones and zeros. Now ones and zeros, they are logical values. Internally, microprocessors, they are digital electronics devices. So they store all this information or this data in the form of charges. Okay, so all this data, it is converted into voltages, and then internally those voltages are stored either in the form of charges or in the form of states of a transistor or something like that. Okay, so it depends upon the type of medium that you're using. Okay, so the CPU or microprocessor does all the processing, and then the data that has to be processed, the results of processing, and the program that processes, that basically tell the microprocessor like how to process that data, all of it is stored in the memory. Okay, now I mentioned here two types of memory. One is primary memory, one is secondary memory. Primary memory is the memory that can be directly accessed by the microprocessor, like your RAM, random access memory. And secondary memory is the memory that cannot be directly accessed by your microprocessor. Okay, like your hard drive, optical drive, the USB flash drive that you connect to your computer, or if you have a smartphone. So for example, when you say I have a 64 GB Samsung Galaxy S8 or S7, so the 64 GB, that is the size of the secondary memory, okay, the ROM, the permanent memory in which you can store your images, photos, videos, audios, text messages, and all the software or apps that you download, okay. So that is the secondary memory. Usually when you're buying smartphones and all that, you do not you're mostly not interested in the size of primary memory. Usually it is around 3 GB or 4 GB or 2 GB, something like that, primary memory. So primary memory is your random access memory. It is the memory that is directly accessible by your CPU. It is important. Why? Any program that you want to execute, it must be loaded into the primary memory. Any data that you want to process, that data must be loaded into your primary memory. So the presentation that you're looking at, so this presentation is loaded in the RAM of my laptop. The audio that is being recorded, and the video that is being recorded, so first it goes into the random access memory, and then from there it is stored into the secondary memory or my hard drive, okay. So this is important, you should know about these things. Now primary memory is usually volatile. Volatile, by volatile we mean when you turn off your computer and you turn back it on, so the contents are erased, okay. So if I restart my computer, so these presentations, these will not be loaded. I have to go to my hard drive and double click on this presentation, reload it again, okay. Secondary memory is something that we call non-volatile. Non-volatile means the contents stay no matter the power is up or down. Whether the power is up or down, the contents remain there, okay. So the contents of the data that you've stored on your hard drive, it is permanent, kind of permanent, okay. Whether there is power or whether there isn't any power, it doesn't matter. So you can turn off the computer and you can turn it on after a week or so, and the data that you've stored on your hard drive, it will be there, okay. So this is difference between these two things. The primary memory, it is called primary memory because it is directly accessible by the CPU, and this is important. Direct access by the CPU is important. It has implications, important implications. If you want to run a program, it must be loaded into primary memory. If you want to process some data, it must be loaded into primary memory, okay. If you need to store the result of your processing, you need to store those results in your primary memory first. From primary memory, then you can shift it or move it into secondary memory, okay. So this is important. And then every computer system has some sort of output, okay. So computers, they process data, and then the results of those processing, those must be communicated to the user. So one example is this display. So this, you can see the results of your processing on this display, okay. For example, if I press the or click on the slide, so I'll be taken to the next slide, okay. So this is the result of processing. If I press the back arrow key, I'll be taken to the previous slide. This is the result of processing. I give the input, the computer processes that input and then shows me the result on the screen. So I press the right arrow key, I'm moved to the next slide, okay. So I see the output here, okay. So I hope you have idea about this. Any computer, okay, if it has some sort of any device, electronic device, digital electronic device, if it has some sort of input mechanism or some sort of mechanism to get input, to store that input or data in some form of memory, it has a microprocessor that can process that data by executing a program that is stored inside this memory, and it then can show you the results in some form on a display, on some speaker, by turning on some compressor or a heater or a fan, or by turning on some other motor or something like that, any actuator kind of thing. So that means it has output. Now if it has these components, then it is called a computer, okay. That is what we mean by the organization of a computer. Okay, so these are the essential components of any computer system. So I hope you know what a computer is. So computer is a data processing machine. The microprocessor or central processing unit does the data processing. Okay, uh, it processes the data which is stored in the memory by following or executing the program which is also stored in the memory. And by memory we mean the primary memory. Okay, the data, how does the data get into memory? So definitely it has to come from some input device. That can be a mouse, a keyboard, a sensor, a mic, a camera, any device. Okay, and once you process the data, how do you show the results of your processing? So you need some output device. It can be a display, speaker, some sort of actuator. Okay, so if we have these components, then we have a computer. And you can program that computer. Like, you should be able to program that computer. So I hope you know what a computer is. Now, what type of data does a computer process? Okay, so we'll talk about data as well. Now, we've talked about data. Data is basically raw facts. Okay, data is basically raw facts. Facts can be quantitative, numbers, or qualitative. Okay, so qualitative means we can have some text, and that text can have the description of something, or something like that. Okay, so it may not be a number, although you must remember a computer is a digital electronic device. A computer is a digital electronic device. So everything that you store on a computer, all types of data, whether they are qualitative, whether they are quantitative, these data must be converted into binary ones and zeros. Okay, these data must be converted into binary ones and zeros. That is how the computer can store it, and that is how the computer can process it. Okay, so whether the data is numbers, integers, or real numbers, doesn't matter. Whether it is text, like the one that you see here, types of data, TYPES. So all these have to be translated or converted into binary ones and zeros. Okay, similarly, if the data is logical means true or false, it has to be converted into ones and zeros. If the data is in the form of an image, like you use digital cameras and you take photos using your phone, and then you process those images. So the image, which is basically nothing but a light signal, okay, it basically measures the colors on different pixels and their intensities on those pixels. So it is basically light. Images are nothing but light. So light has to be converted into numbers. Okay, light has to be converted into numbers, and those numbers can be stored in your memory, and they can then be processed by your computer. Audio. Okay, so audio, it is basically a time series signal. Okay, so like right now I am speaking and my voice is being recorded, and my voice is basically a one dimensional time series signal. So with time, so the signal is being generated and it is being recorded. Okay, so audio also is converted into binary ones and zeros. Everything is converted into ones and zeros. Whether we process video, so right now we are also recording video. So video is basically images plus audio. So it is also encoded in the form of ones and zeros. So all the data, our computer can process all these types of data. Now in programming, especially programming using C++, so we will not be processing images and audio or video, although processing images are nothing but two-dimensional arrays. Okay, so we'll talk about arrays, what arrays are, and images can be represented as arrays. So we won't be processing images, but we will definitely be working with numbers, both integers and real numbers. We'll also be working with text. Okay, like your name or like any other text. We'll also be working with logical data types. So we'll be working with these different data types or different types of data, and we'll be processing these different types of data using our computer. Okay, but never, like you can also process images, audio, and video using your computer. Okay, you can do that. Doing it using C++ is a little challenging, not challenging, but given your understanding of your C++ at this moment, you may not be able to do it right now. Okay, so you have to take a couple of courses of C++ in order to be able to do that, in order to be able to process images and audio or video with C++. Okay, so this is a little bit of advanced material with C++, but nevertheless you can use it, you can do it using computer, and you can do it using C++ as well. Not now, maybe sometime later. So why are we talking about types of data? Okay, remember, keep this picture in your mind. Keep this picture in your mind. The picture of what makes up a computer system. Okay, the CPU, the memory, the input, the output, and keep the definition of a computer in your mind. A computer is a data processing machine. Okay, so here we are talking about the types of data that we can process with a computer, and then we will talk about what kind of processing can be done on this data. Like, what do we mean by processing data? So I gave you an example, the example of temperatures. So one was like, if you want to find what is the maximum or minimum temperature. So that processing involves comparing 300 values and finding out the minimum and maximum. The other was finding out the average temperature on a particular day or for a particular month. So that involves addition and division. Okay, so we can have different types of processing. So first, you need to always remember that a computer is a data processing machine. So what are the types of data that we can process using computer? So all these types of data we can process using computer. And then what does processing entail? What do we mean by processing? So processing can mean different things. Okay, so if you look at different problems, for example, if you have a problem of finding out the minimum temperature or the maximum temperature, that is basically comparison of values. If you have if you want to find out the average temperature during the day or for a month, that is basically the addition and division problem. So there you need to do those operations in order to process data. So whenever we talk about anything, you can always picture the definition of a computer. A computer is a data processing machine, and all this course is basically it revolves around that particular definition. So we will try, we are basically trying to learn how to instruct the computer to process the data according to our requirements. That is what we want to do in this particular course. So how does your computer process data? So we know what type of data we can have or we can process. We know about that. Now, how do we process that data? Now, these are the basic operations that are involved in data processing. You can combine these operations and you can then go to do more complex operations on the data. So what are the basic operations? We can perform arithmetic operations with data. We can do addition, subtraction, multiplication, division. We can find out the modulo. We have done that in the lab sessions. Similarly, we can compare data. We can find out about a relationship, whether the left hand side is less than something or greater than something or equal to something. Similarly, we can perform logical operations on data. Okay, logical operations means like we can evaluate different conditions. For example, for example, let me give you an example. If you want to, for example, if you want to play cricket, now in order to be able to play cricket, you need to meet certain conditions. Okay, you need to fulfill certain conditions. For example, you must have a bat, ball, and wickets. That is one. You must have willing players. Okay. Two, you must be all free. You must have time to do that. And four, you must have a ground to play. Five, the weather must be right to play cricket. Okay. So if you have the equipment, the right equipment to play cricket, if you have willing players to play cricket, if all of them are free to play cricket, if you have a ground to play cricket, and if the weather is right to play cricket. If all these conditions are true, then you can play cricket. Okay, so these are logical operations. So we are basically combining different conditions logically. Okay, so logical operations are and or. If we have the right equipment, if we have the right number of players, if we have an available ground, if everybody is free, and if the weather is right, if all these conditions are true, then we can play cricket. So you might need to do operations like these on data. Similarly, bitwise operations. By bitwise operation, we mean bit is basically binary digit, 1 or 0. So as you know, like all data, it is stored in the form of ones and zeros. All data and instructions, the instructions that you give to your computer, the programs that you write, it is also translated into ones and zeros. Your computer can only understand ones and zeros. Okay, so ones and zeros is the language of your computer, is the language of your microprocessor. It is called machine language. So whenever we use the term machine language, you picture ones and zeros. Everything has to be in binary ones and zeros. Okay, why ones and zeros? Why not some other numbers? So it is because computers, the unit of structure and function of a computer is a transistor, and a transistor is an electronic device that is used as a switch, inside a computer. A switch has two stable states, on and off, 1 or 0. Okay, so we do not have electronic switches that have more than two stable states. Okay, so the best electronic devices that we have right now are transistors. Why are they the best? They are the best because they operate at the speed of light, they are fast, and they have these two stable states, on and off. You can keep them in these two stable states, on and off. Okay, so that is, they have these two stable states. So a transistor can be used to store a binary digit only. Now a binary digit is either 0 or 1, so it has these two possible values. So a transistor can also have these two possible states, 1 and 0. Okay, so all data, it is ultimately converted into bits or binary digits or ones and zeros. So you can perform operations, bitwise operations, that basically perform on the bits directly. So you may have two numbers and we can perform bitwise operations on those two numbers. Okay, so these operations are different than arithmetic operations. Okay, similarly, computers can evaluate, find out the sine, cosine, log, exponential, all these functions. Computers can do data transfer. Okay, they can copy data from one place to another place. Computers generally, they do sequential execution. So this should be your assumption. A computer can and most often does sequential execution. When you give a set of instructions to a computer, when you give a program to a computer, the computer executes that program sequentially, in a sequence. So all your instructions, they have an order. Instruction number 1, 2, 3, 4, 5, 6, and those instructions are executed in that particular order. So computers can do sequential execution, and computers can also do parallel execution. Okay, so say for example, we have Core i5. I have Core i5 on this laptop. Now Core i5 has two physical cores. That means it has two separate physical microprocessors, and those two separate physical microprocessors, they can execute two different programs at the same time. So say for example, right now I'm running Microsoft PowerPoint, and then I'm recording this screen, video and audio. So the operating system, the Windows operating system that I have on this computer, it basically assigns different programs to those different cores that I have. Okay, so a computer can do sequential execution as well as parallel execution, but whenever a computer is executing a program, it executes that program sequentially. So the first instruction is executed first, then the next one, then the next one, and then the next one. Computers can repeat the execution of a set of instructions. Repetition, they can do repetition. Okay, so this is also very important. That is why computers are very useful. They can do a certain task repeatedly without getting tired or bored. They can do that. And computers can do conditional execution. Computers can test a condition, whether a certain condition is true or not, and then execute a certain code. For example, if we go back to our example of the air conditioner, so the computer code inside the air conditioner's microprocessor, like it can test whether the room temperature is greater than the set temperature or not. If the room temperature is greater than set temperature, then turn on the compressor. If the room temperature is less than the set temperature, then do nothing. Okay, just check the temperature once again, or turn off the compressor. Okay, turn off the compressor. So this is called conditional execution. You test a condition. If a certain condition is true, then you execute a certain code. If a certain condition is false, you execute another piece of code. Okay, this is also important in decision making and making your code useful. We'll do that. Okay, we'll do that in our examples as well. So these are the different ways in which your computer can process the data. So let's go back to the definition of a computer. A computer is a data processing machine. This is its general organization and architecture. Now, what are the different types of data that we can have? These are the different types of data that we can have. And what are the ways in which we can process the data? So these are the different ways in which we can process the data. And we can combine these different ways to do more complex operations on data. Okay, so you should have these clear ideas about computers, data, and data processing. And as a programmer, you need to be able to, like, you should ask, okay, since computers are data processing machines, and I am a programmer, and I have to write programs, and those programs will process data in the way I require those programs to process data. So how can I store data inside the memory of a computer? How can I access that data? How can I operate on that data? How can I repeat a set of operations? So you should be asking all these questions in any about any programming language, and you should learn the syntax for doing all these operations in that language. Okay, so keep all these things in mind, and keep the very definition of a computer in your mind. A computer is a data processing machine. Now this, like, it may sound repetitive and boring, but this is how it is. This is how you can link everything that you learn in this course. So how do you make your computer to process data? How do you make, what is data, and what are the types of data, and you should have an idea about data processing. I hope you do. Sorry. How do you make your computer to process data? Okay, so making your computer to process data, this is called programming. Programming is basically asking your computer to do things for you, or giving instructions to your computer to do things for you. This is programming. This is what we call programming. Okay, programming is asking your computer to process data for you according to your requirements or your specifications, the way you specify. That is programming. Now, a computer is a programmable machine. Any programmable machine can be programmed. You can give it instructions to do things for you. Okay, so what is a programmable machine? It can be told what to do, how to do, and for how long to do. Okay, so this is very informal kind of definition of a programmable machine. Okay, so you can tell a programmable machine what to do, how to do, and for how long or how many times to do. Okay, so you can do that. Now, the instructions that you give to a computer, they make up your program. They are called your program. What is a program? A program is a set of instructions that you give a computer to perform a specific task. Okay, so that is a program. So you can have many different programs, like examples of programs. For example, like if you go to some function, if it is a formal function, so you get a program for that function, like what will happen in that function and in what sequence will it happen. First, the guests will arrive. Second, the guests will be seated. Third, maybe the chief guest will arrive. Fourth, the program or ceremony will formally begin. There might be some recitation or naat or tilawat. Then there might be some welcome address. Then there might be some other activities. Then there might be the chief guest might deliver a speech, and then there might be a closing of the program, and there might be then refreshments. So this is a, there are a number of steps that are specified, and then there are a sequence to those steps, like how would those steps be performed in what sequence. So a program is nothing but a sequence of instruction. Say for example, if you want to make for example, if you want to cook something, if you want to make biryani, okay, now this is a very good example of how data processing works. So while making a biryani, you have some raw ingredients. You have rice, you have, say, onions, tomatoes, chilies, you have beef or mutton or chicken, based upon which kind of biryani do you want to make. You have oil, you have all those spices and things. These are your raw or rough ingredients. Then you have a program, somebody, some expert, some person who is expert in making biryani. They gave you the instructions. Okay, take the rice, soak them into water for this much time, and then take the onions, chop them into this size, take the tomatoes, get the oil, and then first do this, then do this, then do this, then do this. Okay, so that is your program. You follow those instructions, you get the raw data, perform on it, and then you get your output, the biryani. Okay, so that is your information. So you can think of this process as raw data, the raw ingredients, the program, the instructions that an expert wrote for you. Okay, पहले ये करें, फिर ये करें, फिर ये करें, फिर ये करें, and the output is your biryani. Okay, so you can think about it in those terms. Now, if somebody has to give you instructions, those instructions must be in a language that you understand. Maybe it can be in English or Urdu or Pashto. This course is about instructing the computer to do things for you. So then we have to do that in a language that the computer can understand. And the language that the computer can understand is the machine language. It is the language of ones and zeros. Okay. Now, the language of ones and zeros is difficult for you to understand. For us, it is not difficult for understand, but if we want to be productive, if we want to write a lot of programs and big programs, so that is not possible with machine language. Okay. An improvement upon machine language is assembly language. Assembly language is nothing but the machine language in English. Okay. So what we do is every machine language instruction is basically written in something that is a little close to English. It is not exactly English, but we use mnemonics to represent every machine language instruction. Mnemonics, by mnemonics we mean like an assembly language instruction can be add A comma B. Okay, add A comma B, A double D, and then A comma B. So this would be an assembly language instruction, and it would be translated into the equivalent machine language instruction. The software that does that translation is called an assembler. Now you will learn about machine language and assembly language in a course on embedded systems. That would be around in 5th semester maybe. So you learn more about assembly language and machine language in that, and I hope like you will learn about assembly language programming in that course as well. In this particular course, we don't work in assembly language or machine language. We work in a high level language such as C++. So you've looked at C++ programs. You write programs in C++ high level language. Now you can do it in high level language because it is easy for you, but your computer needs to execute those programs. So that program needs to be translated into machine language. Okay, it needs to be translated into machine language. So we do the translation as well. We don't do it by ourselves. We ask a compiler, another software, to do it for us. Okay, so we do that as well. So this is how we make our computer to process data. Okay, so we basically write programs to process data, and then we write those programs in a language that we understand. Once we are done writing it, we translate that program into a language that the machine understands, which is the machine language, the language of ones and zeros. Now, what are those steps? We have talked about it. So let us go over it again. How do we program our computer? Now, these steps, these are understand the problem and develop an algorithm. These you need to do in any case. Okay, these may not be part of the process of actually writing the program, but in order to solve any problem using a computer, you must understand the problem first. Like, what is the problem? What is the input that you have? What is the output that you need to generate? So you need to have a clear understanding of the problem, in what ways the data is going to be processed, and how it is going to be processed. So once you understand a problem, you can develop an algorithm to solve that problem. What is an algorithm? An algorithm is nothing but a sequence of steps that you need to follow in order to solve a problem. So you must have well-defined steps or operations, and you must specify the sequence in which those operations need to be performed in order to solve that problem. That is what an algorithm is. Once you have an algorithm, then you can start writing your source code. Okay, your source code is basically your high level language code that you write in order to solve the problem. That is your source code. Now, writing your source code, this process is called editing. This process is called editing. We have talked about it before, and you have in your handout for the first lab, you have, like, we have explained it in pretty much detail, but let us repeat it again. So you write your source code. This process is called editing. In order to write your source code and make changes into it, you need a software that is called an editor. Okay, you need a software that is called an editor. Now you can, if you're using Windows, you have Notepad. The Notepad is a text editor. You can write your C++ code using the Notepad as well. Okay, so you can do that. All the source code that you write, it is organized into two types of files. If you're writing source code in C++, so it is organized in two types of files. One are your source files, the others are your header files. Source files contain your C++ source code that do all the work. Header files, they contain the declarations or definitions of your functions. Okay, so we'll go into more details about the header file in our later lectures, but they are, both of these are text files that you can create with the editor. The source files, they have the extension of .c++, and the header files, they have the extension of .h. Now header files, as the name suggests, they are header files. They come before. So if you remember our discussion about the first C++ program that you wrote, so at the top of your C++ program, you include all the header files. And the header files, they basically include the declarations of all the functions that you might be using in your source file. Okay, so we'll talk about functions and all these things later on, but nevertheless, remember these terms for now, and hopefully by the end of this course you will have a very clear idea about what do we mean by all these things. So once you write your source code, once you're done editing your source code, you have written it and you think like it does your job, then you need to translate this source code into machine code so that the machine or microprocessor can also understand it and execute it. This step is called compiling. Okay, it is called compiling. Compiling is basically translating your source code, which is written in a high level language like C++, into machine code. Okay, so this translation is called compiling. It is done using a software called a compiler. Once the source code is translated into machine code, we call that machine code as object code. Object code is machine code. It is in the form of ones and zeros. Okay, but we call it object code. Why? Because like it is not executable. The machine does understand it, but this object code is not complete yet. Okay, this object code is not complete yet. Okay, it has some missing components as well. It has some missing object components as well. So the next thing that we need to do is link our object code that was generated by the compiler to the object code that is pre-compiled and that we are using in our program. Okay. So this step is called linking. Linking means linking our object code with the object code that comes pre-compiled and that we use in our code. Okay, so if you recall our examples, so we print text on the console screen by saying cout, and then we give it some text, and that text is printed on the console screen. Okay, now we didn't write the code for that, code for cout or cin. We didn't do that. That code is pre-compiled, pre-written by someone else, and we are using it in our program. So we need to get the object code for that particular cout and cin, whatever we are doing, and we need to link it with our own object code, the code that we have written and produced. Now this requires a linker. It is a software and it is called a linker, and what it does is it links all the object codes that we are using with our object code that we produced using the compiler. Once these object codes are linked together, we get an executable file, executable code. That file has the extension .exe. Now that file can be executed by our computer, by our microprocessor. We can double click on that file and it will be executed. Okay, so in order to execute any code, it has to be loaded into the primary memory or RAM. Okay, so this step is called loading. This step is called loading. We need to load the code from the hard drive into the primary memory. We need to load that file, the executable file. In order to do it, we need a loader. A loader is usually part of the operating system. So this software is called loader. It loads the executable files into the primary memory or RAM, and then it asks your microprocessor to execute it. Okay. So these are the steps through which we can program our computer and through which we can solve the problem. So once the code is up and running, then we can see whether it solves the problem or not. Okay. So if it doesn't, then we need to repeat these steps. There may be a problem in the understanding of the problem. There may be a problem in our algorithm, or there may be a problem in the source code. The source code does not implement the algorithm properly. Okay, so we need to repeat these steps until we solve the problem using computer. Okay, so this is basically how we program a computer. So this is the end of this lecture, and in this lecture we talked about the course, we talked about computer as a data processing machine, we talked about what data is and the different types of data, and what processing is and the different types of processing operations that can be performed on data, and we also learned about how we can program our computer. Okay, now many of these things we'll keep on repeating these things in our upcoming lectures as well. Okay, so I hope like this repetition will help you. It will help you master, like learn these concepts and absorb and internalize these concepts, so you have a very clear idea about what all these things mean. This is the end of this lecture. I'll see you in the next lecture. Allah Hafiz.